All right, guys, we're going to go ahead and start talking about predicting the products of chemical reactions. Now, we've talked about so far of how to write reactions. We talked about how to balance reactions. Now we're going to talk about predicting the products, okay? Hopefully we're going to learn to predict the products in very simple reactions. And we're going to look at each type of reaction, so the 5 basic types. And for this, we'll need to identify the types for more complex reactions, but not predict the products. Okay, so basically here we're just looking at very simple reactions to predict the products from, and then in the more complex, we won't have to predict, just label what they are. Now our first reaction we're going to talk about is a synthesis reaction. Remember, that is when many compounds or elements combine to make one compound as a product. What we have to do, we know that a synthesis reaction is going to make a binary compound, meaning it's going to start with just 2 elements. Now what we have to do is we have to find the ions created by each reactant. We crisscross those to make our product because it's going to be a binary compound. So here we see that we have barium, and it's a metal, and it reacts with solid sulfur. And guys, on these simple reactions, we see that here a synthesis is just going to be between an element plus an element. Okay, so if we see an element plus an element, meaning like barium and sulfur reacting together, we know it's going to be a synthesis reaction. So here we take barium and write Ba, and it's reacting with sulfur, which is just S. Now, one thing when writing elements, we always have to check and see if they're a diatomic molecule. These guys are not, so we just leave them like that. Next thing we do is we find out what the ions they have, meaning we need their oxidation numbers. So barium is in group 2, so it's going to have a +2 oxidation number. Sulfur is in group 16, so therefore it has a -2 oxidation number. We crisscross these guys and we get Ba2S2, okay? And we can reduce that down to just BaS. So here we predicted the product. We have a binary compound to finish with, so we're done. Next example, here we have magnesium metal and reacts with bromine. So we have magnesium, which is Mg, and it's not a diatomic, so we leave it like that. Reacting with bromine, which is Br. Now it is a diatomic, so we put Br2. Okay, now all we have to do is figure out, well, what are the ions? So magnesium is going to have a +2 oxidation number because it is in group 2, and bromine is going to have a -1 oxidation number because it is in group 17. We crisscross these guys and we get MgBr2, and that will be our product. Now, in a decomposition reaction, we know that it is, first we're going to be starting with a binary compound. So we saw in the synthesis we're starting with 2 elements. Here we're going to start with a single compound. Now what we're going to do is we have to find the elements that will be created, meaning we have to break that compound up, and all we're going to do in the product is just write them in their natural state. So our first example, we see that we have solid silver oxide is heated. Okay, so to start off with, we need to have the formula for silver oxide. So we know that silver is Ag, and we know that oxygen is O. Now silver has a +1 oxidation number, and oxygen has a -2 oxidation number. We know this because silver is always +1 and oxygen is in group 16, so it's -2. So we crisscross these guys and we see that we're going to start with a compound of Ag2O. And it's going to produce, we're going to produce just the elements. So it's going to break apart into silver and oxygen. Remember, when we write elements, we need to check, are they diatomic? Silver's not, but oxygen is, so we put a 2. Okay, moving on to our next one. Here it says that water undergoes decomposition. So everybody knows that water is H2O. It's going to break up into its parts of hydrogen and oxygen. We check and see, are they diatomics? Hydrogen is, and oxygen is. Now a single replacement reaction, what we know about it so far is that a single replacement reaction usually has an element in the compound, in the reactants, and in the products. So when we're looking for it here, if we see that in the reactants we have an element and a compound, then we know we're going to have a single replacement reaction. Now in a single replacement reaction, remember that the similar elements in the compound will switch with each other. Okay, so what we have to do is we have to find the ions that are created, and we have to crisscross to make the new compound. So for example, we have zinc metal is added to a solution of lead 2 nitrate. So we break this up into its parts, and so we have zinc, which is our element, and then we have lead 2 nitrate, which lead we know is Pb, and that 2 tells me is a +2 oxidation number. And then nitrate's a polyatomic, it's NO3, and has a -1 charge. So we crisscross those guys to get what we're starting with, and we get Pb, NO3, 2. Okay, and it reacts to form. We know that since zinc is a metal, it's going to switch with lead. So zinc is now going to be bonded to nitrate. So we put lead by itself, just Pb, and then we have to crisscross to make our new compound, which we have zinc. Zinc is a +2 oxidation number. We just have to know that. And then we have lead, nitrate, which is NO3, and it has a -1 charge. We crisscross. We see that we're going to end up with ZnNO3, 2. Next example, we have sodium iodide is added to chlorine gas. So sodium iodide, we have to mix those guys together. And what we see we're going to get, sodium is Na, and iodine is I. Sodium is +1, iodine is -1 because sodium's in group 1, iodine's in group 17. Crisscross, and we see we get Na, I. And then it has chlorine gas, which is Cl. We always check when we write an element, is it a diatomic? Chlorine is, so we put a 2. Now in the products, we see that chlorine is a nonmetal, so it's going to switch with the nonmetal in the compound. So chlorine is going to now be bonded to sodium. So we'll have iodine by itself. We check, is it a diatomic? Yes it is, so we put I2. And then we have sodium now bonded to chlorine. So sodium is Na, which is +1. Chlorine is -1. We crisscross and we get NaCl. Now, our next reaction that we have is a double replacement reaction. And in a double replacement reaction, what we see is that the similar elements, meaning the metals, are going to switch places, and they're going to make 2 new compounds. Main thing here, in a double replacement reaction, we can look and see that if we have a compound plus a compound, we're going to have a double replacement reaction. Okay, and we're going to have 2 new compounds that we've created. So here we have silver nitrate and sodium chloride solution are mixed. So we take our silver nitrate and we have to crisscross that to make our reactants before we make our product. So silver is Ag, which is +1, and nitrate is NO3, which is -1. We crisscross those guys and we get silver nitrate, AgNO3. And then we have sodium chloride, which sodium is Na, which is +1. Chlorine is Cl, which is -1. We crisscross those guys and we get NaCl. And it produces a product. We see that our metals will switch places. So silver is now going to be bonded to chlorine, and nitrate is going to be bonded to sodium. So we have to re-crisscross on the other side. So we take silver, bond it to chlorine. They both have 1 oxidation number, so it's going to be AgCl. And then sodium is going to bond to nitrate, so we're going to have NaNO3. In our next example, we see that we have a solution of magnesium fluoride and potassium hydroxide, and they're mixed together. So again, we have to do crisscross to make our reactants. We have magnesium, and we have fluorine, and those guys are going to crisscross, and magnesium is +2, fluorine's -1. And then we have potassium, which is +1, and then hydroxide, which is a polyatomic, and it's -1 for its charge. Now we go ahead and crisscross magnesium fluoride, and we get MgF2. And we crisscross potassium and hydroxide, and we get KOH. And it produces a product. The metals will switch places, so magnesium is going to be bonded to hydroxide, and we have our fluorine that's going to be bonded to potassium. So we crisscross these guys, and we see we get KF plus our magnesium hydroxide of MgOH2. And all we did was we crisscrossed those with their new partner. The last reaction we're going to talk about is a combustion reaction. Now we know that it makes water and or carbon dioxide, and we just choose the element that is, or choose the product that is in the reactants to begin with. But remember that a combustion reaction is just when we have something reacting with pure oxygen. So here we have an example of carbon reacting with oxygen. So we have carbon plus oxygen, and it'll produce here CO2, okay? Because we don't have any hydrogens to deal with, so it can't produce water, okay? So we're starting with a compound reacting with oxygen. Here we see that we have methanol, and it's reacting with oxygen in the air. So what we see is we have C2H5OH reacting with O2, and it will produce carbon dioxide and water. The reason why I know it's a combustion reaction is we have a compound reacting with pure oxygen. Okay, now let's go ahead and let's work some examples. First, we want to identify the type of reactions, predict the product, and then write the balanced chemical equation. So starting off here, we have hydrogen sulfide gas is bubbled through a solution of potassium hydroxide. So the first thing we have to do is write out our reactants. We have hydrogen sulfide, so we have hydrogen reacting with sulfur. And we have to crisscross these guys, so we have hydrogen, which is +1, and sulfur, which is -2. We crisscross those guys and we get H2S. And then we have a compound of potassium and hydroxide. So we have potassium, which is +1, hydroxide, which is -1, and we crisscross those guys and we get KOH. So the type of reaction that we're going to have here is we're going to have a double replacement reaction because we have two compounds. So we know that in a double replacement reaction, the metals switch partners. So now we're going to have hydrogen bonded to hydroxide, which when we crisscross hydrogen with hydroxide, it makes water. And then we're going to have potassium crisscrossing with sulfur, which will give us K2S. Okay, so now we have to go ahead and balance it. When we're balancing this guy out, we look and we see that we have hydrogen, sulfur, and potassium and oxygen in our reactants. We count up how many we have of each. We have 3 hydrogens. Don't forget 2 over here, 1 right there. And we have 1 sulfur, we have 1 potassium, and we have 1 oxygen. And remember again, guys, on balancing, I'm just looking at the subscripts to count up how many I have of each. Now in the products, we see that we have 2 hydrogens. We only have 1 oxygen. Here we have 2 potassiums and 1 sulfur. So I see that what's not balanced are the hydrogen and the potassium. So what I'm going to go ahead and do is balance the potassium first. I'm going to go ahead and put a 2, and we're balancing it in our reactants. So we put a 2 there, which changes my potassium to a 2, and it becomes balanced. But now it also changes my oxygen to a 2, and it changes my hydrogen to now 4, because I have 2 right here, and then 2 over there, so it becomes a 4. And to balance it from here, I see that my hydrogens and oxygens aren't balanced in my product, so I have to put a 2 right here, which gives me 4 hydrogens, and we see that we have 2 oxygens. And I see that everything is balanced now, and that's my final equation. So written all nice and neat, we can see we have it just like this. It's a double replacement reaction, and that's our balanced chemical equation. Moving on to our next example. Here we have liquid butanol, and it's burned in oxygen gas. So we know we're going to have a combustion reaction because we have a compound plus oxygen. It's a combustion reaction. So we go ahead and we write our reactants. We have our C4H9OH with our oxygen gas, and it produces carbon dioxide and water. And guys, anytime we have a combustion reaction, it takes a lot of coefficients to balance it. And we see that now it is balanced with these coefficients. Moving on to our next example. Here we have liquid bromine is mixed with sodium iodide. Guys, to make this, we have bromine all by itself, which is just Br. And we put a 2 because it's a diatomic. We have sodium iodide, which we have sodium, which is Na, which is +1, iodine, which is -1, so we have NaI. And we see that in this reaction, it's going to be a single replacement reaction because we have an element by itself in a compound. So in a single replacement reaction, we see that the like elements will switch places. Bromine's a nonmetal, iodine's a nonmetal, so they'll switch places, and now bromine's going to be bonded to sodium. Okay, iodine is going to be all by itself, so it's just I2. And we see that bromine is now going to be bonded to sodium, and we see that bromine has a -1 oxidation number, so therefore we crisscross and we get NaBr for sodium bromide. Now we have to go ahead and we have to balance it. We see we have 2 bromines and 1 bromine, 1 sodium, 1 sodium, 1 iodine, 2 iodines. So we'll balance the bromines first, put a 2 right here, which changes my bromine to a 2, changes my sodium to a 2. So I got to come back over here, balance my sodiums, and I see that now I'll have a balanced chemical equation. Here it's written nice and neat for us, where we have our single replacement reaction because it's an element plus a compound, and then we have our bromine plus our sodium iodine producing our sodium bromide and our iodine. Okay, move on to some more examples. Here we have calcium metal is heated strongly in nitrogen gas. So we have calcium, which is just Ca, and we have nitrogen gas, so it's just N. Check and see, are those 2 diatomics? Nitrogen is, so we put a 2. Then in our products, obviously we have an element and an element. We're going to have a synthesis reaction. So all we do is we take calcium, which we know there's a +2 oxidation number because it's in group 2, and then we have nitrogen, which is in group 15, so it has a -3 oxidation number. Crisscross those guys, and we get Ca3N2. So to go ahead and balance this, the only thing that's not balanced is our calcium, so we're going to go ahead and put a 3 right here, which now we have 3 calciums, 2 nitrogens, 2 nitrogens. Okay, written all nice and neat. We see that we have 2 elements, which is our synthesis, sodium, to our calcium, and it makes our calcium nitride. Okay, in our next example, we have liquid water is decomposed through electrolysis. So we're starting with H2O. Okay, decomposition means we're going to break it up in its parts. We'll have hydrogen plus our oxygen. They're both diatomic, so H2O2. And we see that here, oxygen, we have 1 over here, 2 over there. It's got to be balanced, so we put a 2 right there. Changes our oxygen now to a 2, but change our hydrogen to a 4. So we balance that guy out by putting a coefficient of 2 in front of the hydrogen. Okay, written all nice and neat. We see we have a decomposition, and here's our balance equation.